afternoon, everyone. I welcome you back to Dr. Ray class. Now let's see how we can solve this question together. A radio station emits waves of frequency 96 megahertz at a rate of 100 kilowatts. Calculate the number of photons emitted per second. And here we are given Planck's constant to be 6.63 exponential minus 34 joules second. Now let's look at a very simple way we can solve this problem. Now, to understand how easy this question is going to be, you need to remember that this is based on quantum theory. First, bring out the parameters, that means the information provided in the question. We have the frequency as 96 megahertz. The best thing is put it in the SI, which is 96. Mega means times 1 million. That means 10 raised to the power 6 hertz. Now what else was given? Say at the rate of 100 kilowatts. What quantity is measured in watts? Is power. So we have power as 100 kilowatts. So you write the 100, which is this. Kilo means times 1000. 1000 is 10 raised to the power 3 watts. Now we have Planck's constant H, 6.63 times 10 raised to the power minus 34 joules second. So we have the three things given to us in the question. Now I'm going to state this. From quantum theory, the energy of the quanta is given by NHF. E here represents the energy of the electromagnetic radiation. N here represents the number of quanta available, or the number of photons. H here is the Planck's constant. F is the frequency of the electromagnetic radiation. Now, if the number of quanta is 1, that means when n, which is number of quanta, when n is equal to 1, it becomes a singular quantum. So you cannot say that E, when n is 1, that means 1 times H is H times F. So HF. Here is the energy for one quantum, or one quantum rather. This is the energy for one quantum. Now if you now have multiples of quanta, this is the formula to use. Now remember that quanta is the same as photons. Then you can say quantum is photon, right? This is coming from the principle that energy of radiation or emission from hot objects or black body materials, their energies come out in bundles, in packets. Each packet of energy is called quantum or photon. They have multiples of them. That's when you say quanta or photons. Now for one quantum or photon, the energy is given by HF. That means for multiples of quanta or photons, the energy is given by E equal to NHF. This is the number of photons we're asked to find. But there's a little twist. We're asked to find number of photons emitted per second, not just number of photons. So that means the whole of this formula over time. Now, do you remember that power is equal to energy over time, right? If you remember this, and the energy of the photons is NHF, that means we can say power is equal to NHF over time. number of photons per second. Number of photons per second. So we need to make n over t subject of the formula. For us to make only n over t subject of the formula, which is number of photons per second, we need to remove hf as a multiplier here. For us to remove it, we need to divide both sides by hf. So I'm going to divide here by hf. That means I have to multiply here by 1 over hf. This will eliminate this. So we have number of photons per second, where the number of photons per time is power divided by Planck's constant multiplied by frequency. And if we put this substitute values, we have power as 100 times 10 raised to the power 3 divided by Planck's constant is 6.63 times 10 raised to the power minus 34. Frequency is 96 times 10 raised to the power 6. Okay. Having said that, we have here that number of photons per second is, our power is still 900 exponential 3 divided by, here I'm going to multiply the product of the denominator, 6.63 times 10 raised to the power minus 34 times 96 times 10 raised to the power 6. That will give 6.3648 times 10 raised to the power. So the product of the denominator here will give us 6.3648 times 10 raised to the power minus 26. So I will divide 100 times 10 raised to the power 3 with 6.3648 times 10 raised to the power minus 26. We have that number of photons per second is 1.57 times 10 raised to the power. So our division gives 1.57 times 10 raised to the power 30. So it means for every second, 1.57 times 10 raised to the power 30 photons are emitted. And if you think about it, that's a very large number. So that's why the emission appears as wave. Of course, we know that quantum theory here you are, or let me say, wave particle duality teaches that you can explain this as matter, you can explain it as wave, depending on the situation you are dealing with. In some cases, electromagnetic radiation are being described as wave. In some cases, it's being described as matter. So here, we are looking at it as matter, not as wave. So it's as if these are coming out like grains, like bullets being shot from a gun, not as a stream of water flowing as we understand electromagnetic radiation to be waves. In this concept, you have to look at it as if it is matter being counted in numbers. And that's what we have here.